to another Science Time Live. It's me, Bunsen Bernie, back again. Today we're going to talk chemistry. So I've got a lot of cool experiments set up for us to check out. So we're going to get started. So first thing that we're going to talk about is pH experiments. So I have in these these three flasks, a couple of different chemicals. Now they are all clear, right here, clear, but they are not the same. So what we're going to do, we're going to check out the pH of each of these. So to this container here, I'm going to add a little more of our sodium carbonate mixture. And if you know what pH is, go ahead and write that in the comments down below. Or if you have a question about pH, write that in the comments below. So we're going to be doing some colorful chemistry. And I actually mixed up a special batch right in here of a pH indicator made from cabbage. So made from red cabbage. So this is our special pH indicator, homemade. You can make it at home, and we'll show you how to in one of our virtual science shorts. So I'm going to get that mixed up just a little bit there. Get that one mixed up there too. And we're going to get to testing. So our indicator here, this is called Universal Indicator Solution. And you can buy this commercially, or again, we can make it at home, but we're going to get to that next. So with our Universal Indicator Solution, we can see it's sort of an orangey red color. When we put it into these different solutions though, it's going to tell us a little bit about the chemical inside of there. As I place these drops inside of here, we can see it gives it a nice reddish color. And again, I'll bring that closer for you. So it gives it a nice reddish color. What does that mean? Well, let's take a look at the other chemicals first and see what color we get with them. So with this one here, we get sort of a pale green color. So we can see it there. And then for our final solution, we'll add a couple drops in there. We can see we get a nice rich purple color there. So why do these change colors, even though before I added that to it, they kind of all looked the same? So we can see, again, red, green, and purple here. Can everyone hear me okay? Do I need to speak a little bit louder for you? I don't have my microphone attached this time because I didn't want to pull the camera over like I did last time. If you can hear me now a little bit better, give me a thumbs up in the comments for me. Alright, so our different solutions that we had here. So we had an acid, we had a neutral solution, and then we had a base, or a basic solution in here. So our acid was acetic acid, also known as vinegar. So vinegar is a clear liquid. It's colorless. It is not odorless though. We know that if we open a bottle of vinegar, it does not smell very good. It smells very strong, but it does still look like water. When we add that solution, the color red tells us that it is an acid. So an acid on a pH scale is anything less than 7 is going to be considered acidic. So less than 7 over here on the left, your left, my right. Right here in the middle, this one is going to be right around 7. This is just tap water. And then this is going to be above 7. This is going to be about 12 to 13 on the pH scale. Now the pH scale ranges from 0 all the way up to 14. And what the pH scale tells us is how many free hydrogen ions are in that solution. So in water, it's balanced out. So there are hydrogen ions, but there are also what we call hydroxyl ions. So they balance each other out. There are almost equal parts. If it were a perfect 7 on the pH scale, that means there are equal parts. If we have an acid, that means there is more hydrogen floating around. So it's a little H+. There's a lot of them floating around in here. And in our basic solution, that means there are less little H+ ions floating around inside of here. And more OH, or the hydroxyls. All right. So we saw with the universal indicator solution that you could buy, or we're going to see what happens with our homemade solution that I just made in my lab, or my kitchen. All right, so we're going to take a little bit of that. And what's really cool about this is it doesn't come with any crazy red labels. It's not flammable, won't hurt you. You can actually quite literally drink this. Would it taste good? I'm not going to find out. So we have our same solutions. We have our acetic acid, or our vinegar. We have our water, and then we have our sodium carbonate and water mixture. So you've probably heard of sodium bicarbonate, which is baking soda. What we're mixing in here is sodium carbonate, which is washing soda. So this is going to be more extreme on the basic end of the pH scale. So we're going to take our dropper here and we're going to drop in some of our pH indicator. So you can see it gives us a nice pink color inside of our acid. And since it's a little watered down, we need to add some more, but you can see it has that awesome pink color. Matches my shirt and my tie-dye lab coat. We're going to drop some in our water now. Now with the water, it should give us a purplish color to a bluish color. And again, we're going to need a lot more because it is a little bit watered down. So it gives us a nice blue color. Hey, it also matches my lab coat. Alright, and we're going to give this one more good stir here. Make sure everything's blended in there nicely. And then we're going to add our pH tester. So this one comes out green. So if you remember with the other indicator solution, it was actually inverse with these two. So our purple one was the base, and then our blue one, blue or purple was the base, and then our green one was actually the water. So it's flipped on those. Make sure when you're looking at a chart that you look up the exact solution that you're using. So again, two different indicator solutions with the same base to it. So we added water for this one. This one had the sodium carbonate, and it gave us two different colors. So make sure you're looking at the proper pH scale when you're doing these tests. All right. So why does this work? What is so special about the cabbage? Well, there are little cells inside of there called anthocyanins, and they are the ones that change color depending on the strength of the acid or the base in the solution. And you can actually make an entire rainbow. If I had more beakers at home, we'd be able to make a lot more colors depending on the solution. So we could do a watered down vinegar solution, half water, half vinegar, and it would change the color. If we did half water, half half sodium carbonate mixture, it would give us a different color. So we're going to get these moved out of the way. And we're going to pour some more acetic acid in here. And I'm going to get some water. And we're going to use a different tool this time. So these are little pH test strips. And these, what's really nice about them is it comes with the scale right on there for you. So our orange color or yellow color, which it is right now, is going to be 2.6 or 6.3 is going to be an acid. If we have a green color, it's going to be neutral, and then the bluish purple color is going to be the base. So we're going to see what we get here. So we just need to add a little bit of sodium carbonate to this mixture here. All right. Grab a stirring rod and stir that up really well. And then we're going to use one strip for each container here. Now with these, again, you do have to buy them, but you can also make your own using the cabbage. So with the cabbage, what's really cool is you just soak in a coffee filter, slice that up, put it in there, and then let it dry, and you'll have your own indicator solution. Now again, make sure that you're looking at the proper scale when you're doing that, because it's going to be a little bit different than mine. So placing it inside of the vinegar here, and then in the water, and in our sodium carbonate solution. So we can see the difference there. And I'll bring these closer to the camera. So this was our vinegar. So remember we said that orange or yellow color is going to give us, or is going to tell us we have an acid. And then a greenish color is going to tell us that it's neutral. This one looks a little more blue. And that's because here in Florida we actually have hard water, which means that it has a little bit of a higher pH. And then this one here is the sodium carbonate solution, gives us that nice blue color. Okay, so remember I am going to answer your questions towards the end of this, so make sure if you do have any questions that you're asking them along the way. Alright, so we're going to do a really cool color change experiment. And for this, I'm going to need some liquid starch. So if you tuned in last week, you saw that my buddy Hydrogen Harry, I miss him so much. You saw that he used the liquid starch to make some slime, and we're going to use it today to cause a chemical reaction. So we're going to use our liquid starch, about 2 milliliters, and then we're going to add some hydrogen peroxide. So you may have seen me use hydrogen peroxide before for our elephant toothpaste experiment. So all these things that we can find in our house, we can do chemistry with them, and it's really, really awesome. So I have inside of here some vitamin C. So our vitamin C is going to provide the citric acid for this experiment. And then inside of here I have a little iodine solution. Now this would work very well with just your standard iodine that you can get in the first aid section of a grocery store. But I wanted to make this a little more spectacular. So I've prepared a very strong iodine solution. And we're going to add in about 60 milliliters of water. There we go. So we've got our hydrogen peroxide and liquid starch in this container. And in this container, we've got our vitamin C as well as our iodine solution. So we're going to stir that up really well. And we're going to place them into the same container. So we're going to do this in the larger container. Uh-oh. I think I may have done something wrong there. It's not changing quite yet. So all reactions are not going to be instantaneous. So we're going to let this one sit for just a moment, and we'll come right back to it. So I'm going to leave it here in your view. And I'm just going to check that we can actually see that in our camera. Okay, so we can see that in the camera. So you can pay attention to that, but also pay attention to me, but also pay attention to that there. And what I'm going to grab now is a pretty advanced tool. It's a pH meter. So this pH meter eliminates the need for all those cool dyes that we used, but it's not as fun. So we're going to add some vinegar into this container, and we're going to see what the pH meter tells us. So if you remember, I mentioned the pH was a measure of the free hydrogen ions in there. So the scale is kind of weird. It's called a logarithmic scale. So that's why it allows us to go from 1 to 14 and not these huge numbers that are there in between. So if we look at our pH scale now, it shows us about 4.3 for the vinegar, which is a little high. pH of vinegar is usually around 3. Now what if we check out just water? So just plain water right out of the tap. We can see it sits right about 8.8, and again, that's a little high. I may need to adjust my pH scale. So right out of the water, it should sit a little higher than 7, which is normal. Again, here in Florida, we have very, very hard water. What if we checked out something like the sodium carbonate? So this should give us a very high reading. Again, it's reading about 13.9 to 14, which is a bit high. So this may need a little bit of calibration. It should sit right around 13 though. Should sit right around 13. So I'm going to rinse this off here. Okay, in our experiment, we're still waiting on it there. I may have to do another one, just in case that one doesn't work, but that's science. Our experiments don't always work. If they did, that would be awesome, but there would be no point in experimenting and trying new things all the time if something worked every single time for us. So while I get this ready, you can go ahead and drop some comments, drop some questions in the comments below, and I'll make sure to get this one working this time. So we've got our vitamin C in here. So it's going to be 1,000 milligrams, or 1 gram of vitamin C. And we just need to crush that. And then we're going to mix that into 60 milliliters of water. There it goes. So it took a little longer than I was anticipating, but it worked. And if you were paying attention, hopefully you saw it go. I did not personally see it go. So the reason that happens is in the presence of the starch. So I put those 2 milliliters of liquid starch in there. In the presence of starch, the iodine is actually a very deep, dark blue color. So if you can see this here, it's a very, very dark color. So in the presence of starch, it is that deep, dark blue color. Well, what's happening is the vitamin C is originally attacking the iodine. It's using it up. And when all of that vitamin C gets used up, just like that, our iodine indicates that our starch indicates that there is iodine inside of the solution. All right, so I've got a beautiful rainbow of colors up here. I'm going to grab my iPad and see if we do have any questions for me here. All right. So I see myself there. We're going to in here. What are some other examples of acids? That is a very good question. So lime juice, lemon juice, and that is actually the reason that those things taste sour to us. So if you were to taste vinegar, if you were to take a spoonful of it, it would taste very, very sour. And that's because of the acid inside of the vinegar. So lime juice, lemon juice, citric acid is also very acidic. And that is put in a lot of candies to make things sour. And in fact, if we take our citric acid and we pour it into one of these containers, so we'll get some citric acid in there, and we can see that pH change. So I'm just going to grab a spoon here. And if we take our citric acid and pour it into here, we'll see that color starts to change. So remember, our vinegar was an acid, and it had that nice pink color to it. So adding that citric acid to it changes it down into an acid. And acids and bases react with each other. Sometimes it can be violently or catastrophically, but luckily these are nice and safe acids and bases to mix here. Excellent question though. What are some other examples? All right. See some more questions coming in here. All right, once again, make sure you're leaving your questions down below. I try to explain everything really well, but sometimes there's questions that I don't think I go over. So hopefully you have some questions coming in. All right, and I'll just keep refreshing here. Why does it look pinky orange? Why does it look pinky orange? Well, that's due to the chemical that's inside of there. So depending on what we have in here, acid or a base, the juice from our cabbage, so remember I made this cabbage juice here, the juice from the cabbage tells us whether it's an acid or a base. So those special little molecules that are inside of there react to the liquid. If it's an acid, it'll turn it the reddish color. If it's a base, remember we had that green color to it. Silly Bunsen, Bernie, your science is really cool. Is it drinkable? Well, our cabbage juice, again, I've never tried it. I'm sure some people like it, but it definitely is drinkable. Not our pH indicator here. So this is a universal pH indicator. So this one It's definitely dangerous to be around, so I prefer the homemade one myself. All right, I'm going to check for a couple more questions here. Why is the cabbage juice purple? Well, I used the purple cabbage here to create it, so it's really super simple to do. All I did was chop this up to about 2 cups of cabbage, and you can see it's only about 1/4 of a head of the cabbage. So I chopped it up really finely and then boiled some water, put this into a bowl, and just put enough boiling water over it so it covers the cabbage. Let that sit for about 10 minutes, and if you'd like to speed up the process, put it in a blender. And that breaks the cells open, and it allows those little chemicals to escape, those anthocyanins. It allows them to escape. So it gives you a really, really dark color. If you just let it sit in the water, it's not going to be as concentrated. If you mash up those chemicals, it will be very concentrated. And then all you have to do is filter it out. That way you have just the liquid, and there are no solids floating in there. For that, I just used a reusable coffee filter that I have, and that allowed it to get just the liquid there. So again, the cabbage juice, the cabbage itself has those special molecules, those special chemicals inside of there that allow it to indicate the colors. So those anthocyanins are inside of there. I don't know off of the top of my head if there are any other plants or fruits or vegetables that do this as well. I can definitely look it up and leave you a comment there and answer that for you though. Alright, so we're going to check for any last questions. I've had a great time today. I hope you guys were having fun. Most of all, I hope you learned something with me today. And I hope you get some inspiration to do, please, try this at home. So again, we're going to post a video about how to make this cabbage. We'll have some instructions on there on how to make the cabbage pH indicator, along with a couple different experiments to try it with. What's really cool is just to grab things out of your refrigerator. So take some apple juice or lime juice, grape juice, take water, and put it inside of the cabbage juice and see what color it changes to. See what color it makes it. Alright, I want to thank everybody once again for joining me today. I am Bunsen Bernie, and I may have one more question. Okay, yes, we have one final question. It was, how did the purple cabbage change to orange? So, again, those chemicals that are inside of there, the acid reacts with them. So, the acid changes the way those chemicals reflect the light. It changes the way that they're behaving inside of the container, and it allows it to be represented as a red light rather than the purple light here. Alright, so again, I encourage you all to try this at home. I want to thank you so very much for joining me for another edition of our Science Time Live here at the Science Center. Well, here at my home, but from the Science Center. We want to thank you. Make sure that you stay safe, stay healthy, and most importantly, stay happy. Thanks again.